Hello and welcome to 5-Minute Math. Today we are looking at Algebra 1 activities for standard A.2A. We are in this blog post looking at how we can determine the domain and range of linear functions, including both continuous and discrete data. So on this blog post, which is on my website, 5minutemath.net, there will be a link to this blog post in the video description. You see a few things before we get to the activities. I'm always going to include the teaching videos, so I call these my TEKS videos because I'm simply using the TEKS to teach students and teachers how they can understand this standard here. So these are the first two right here. And then I also want to see how the students have done on STAR recently. Now, this is based off the entire state of Texas. They've released their item analysis for the state. And as you can see for 2023, this is item number 7. We had 33% get full credit on this. We had a inline choice, and they had to simply describe the range here. And this is a video showing how to actually solve that problem itself. We also had number 46 on 2023, only 34% got correct. We had to find the linear function. They were given both the domain and the range, but it was multiple choice. That's how you solve it. Now, all of the activities on this blog post are obviously free, but they all follow this framework of active, playful learning. This is something that I'm familiar with and a full believer in. If we want students to learn more, we need to have more active, engaging, meaningful, just joyful activities. So none of these are going to be worksheets. They're going to be fun. And it is okay to have fun and learn math at the same time. In fact, that's the best way to learn math. So here are some activities. This walkthrough that I'm doing will actually be tagged right there in the blog post once I'm done recording it. So our first one is a great activity that can work for this and honestly anything in which vocabulary is very important. It's called Talk a Mile a Minute. So you want to pair students up and you want to display a term related to this particular standard. So I've got some examples there in the parentheses: domain, range, x-axis, y-axis. Even if you want to talk about what a closed circle and an open circle means, continuous, discrete, what you're going to do is you're going to literally give 1 minute. Partner A has 1 minute to name as many phrases related to whatever term is shown on the board, let's say continuous. And then partner B, their job is simply to listen and write it down. And then you switch. You show another term. Partner B is the one that names everything, and partner A is the one that writes them down, right? So you've got two different terms that are being shown. Now you give each the partners 3 minutes from each list. Once for the first round, once for the second round. They're going to circle one word that they think will be on someone else's list, like the most common obvious answer, and then one term they think is so unique no one else will have it. One of those on each of those lists. So that's 4 possible words: a unique and a common word on list 1, a unique and common word on list 2, 4 points max. And then you simply go over the circle terms from each list. You won't have many problems with the common terms. This really, as a teacher, gives you an opportunity to just kind of get a pulse on where your students are in regards to their vocabulary. The unique terms, sometimes they're going to say something like SpongeBob, and you're going to have to say, okay, how is that related to the word continuous? Let them give a rationale and let the class be a judge. Does that work? If they can make a connection, give it to them. And if you do this multiple times, kids will really like coming up with some of those unique terms. Here's some variations. Right? You can, kind of like the game Taboo, you can provide a list of closely related terms that are very obvious and just ban them. So you want to force students to cast a wider net. You can just create a list of bonus words, and if they appear on students' lists, they get an extra point, even if it's not circled. So words maybe that you really, really, really want them to list. You want to have pairs. If you're afraid that students are simply listening to their neighbor next to them, you can have students working on different words at the same time through multiple rounds, and that will kind of forestall that cheating of students just listening to what their neighbor's saying. If 2 different partners next to each other actually work on 2 words at the same time. And then you can allow students to select 2 words. You can change how many words they circle. They can have 2 words on their list to reinforce common terms related to the target vocabulary. So there's a few different variations. That's activity 1. It's a ton of fun. Second is graphing manipulation. So we're going to need Desmos here or some type of graphing tool. I just like Desmos because it's what's on the STAR test and it's a lot easier to use than graphing calculators. But if that's all you have, you can use that as well. What you want to do is you want to give students a linear equation for them to graph, right? Maybe y equals 5x. And then you're wanting them to use these curly braces here because that's how they're going to restrict the domain and or the range depending on whether you want them to do one or both, right? So they would write y equals 5x and then the curly braces x is greater than or equal to 1 or y is less than 11. Another thing with Desmos is they don't do open or closed circles, so you really can't get that unique there unless you want to draw over it on your interactive whiteboard. Now, what you're going to do is you're going to give students a series of clues, and they have to meet the clues by restricting the domain and range. For example, restrict the range so that the graph doesn't appear in quadrant 1, or restrict the domain so that the x values are negative. Now you've got multiple different ways that students can meet these expectations. And then sometimes you can, if you really want to mess with it, you can have them change the slope. For example, make the line slope down from left to right. Okay, so now we need a negative slope, or make the line steeper, right? So we need our slope to be larger. And so for each manipulation, right, you have students share the changes, discuss commonalities, view some stuff on the whiteboard if you want to, and really you're just playing around with it. You're getting comfortable with the tool, but you're also just getting used to restricting the domain and the range. Now, what are some variations? You can give them multiple clues at once, right? So give them all of this. Graph a linear equation that A has a shallow slope, B descends from left to right, and C only appears in quadrant 3. That's a lot. But if they can do that, that would be fantastic, right? You can allow students to lead the activity, they give the clues, and then they have to check for correctness. Now, you can have students, draw line segments, right? So graph a line segment with a length of 5 units. Now, if you want it to be a length of 5 units, it's going to have to be horizontal. So if you want it to just be a horizontal distance of 5 units, regardless of slope, you might want to say it that way. And what's really fun is that last bullet. Ask students to draw basic shapes using a series of linear equations. So draw a right isosceles triangle using 3 linear equations. They could do it if they restrict the domain and the range of each of those lines, but they're going to have to get pretty clever to get it done. So our third activity is linear card sort. Students will be sorting linear functions based on the restrictions in the domain and or range. So we're just trying to identify the restrictions here. So you can give each student a set of graphed linear functions. So I've got a start here. This is linked right here. It says see example. And all I did is I went into Desmos and I just created a whole bunch of linear equations here. And I just went to that print image function and I put it into a table on a Google Doc. So that's it. All of these images are just from Desmos. So you can create as many as you want to and just use that print feature. And if you're not familiar with that, let me show you what I'm talking about. You get into Desmos. I'll open it up for us right here. You graph something, so you might say y equals 5x, right? And then I want to restrict. So I want to say x is greater than or equal to 2. Okay. And then I might want to say y is, less than, say, less than 10. Okay. So if we do that, we're going to see that, look, I've got a little tiny dot because, look, if I say y is less than 10, I only have one dot. So let's change that up to 20 so I at least get a line. All right, so now I've got something. If you wanted to graph this, that's what it would look like. And you're going to click this little share graph, and you can export the image. When you do that, you can download it as a PNG. So that's what I'm talking about. So you give each student just a whole set of these. And then what you're going to do is you're just going to give them clues, right? Find all the cards with a domain greater than 2. Or you might want them to find an exact card, so they have 10 cards. Find the card with a range that's greater than 6 and less than 10. Remember on Desmos, you're not really getting greater than or equal to, so If you want to hand draw those, you can before making copies, or you could just leave it with a greater than or less than. But basically, they're either sorting cards where there could be multiple answers to each clue, or you're having them look for the specific one. And then after each card they recognize, have them go ahead and represent it, the domain and the range of any cards that you call as inequalities, right? So you want them to be able to write that in that inequality form for both the domain and the range. So it's a little bit of looking and finding and recognizing, but they're also having to do a little bit of work with this. So what are some variations? So if you want to create some additional cards, this can easily be a center activity, a self-check. It could be a memory match game, right? So you have all of the pictures, you add those inequalities that you're asking them to write that show the domain and the range. Boom, there's your memory match game. Okay, you can do that as well, but put one extra card in there that's either just the graph or just the inequality that doesn't match, and have the kids play Old Maid. Now that would be fun for them to try to figure out how to play that game, but look up the rules for Old Maid. You don't want to be stuck with that Old Maid, the one that doesn't have the match, and they can play that game. You can give students just some directions on how to make a 3x3 grid, maybe on paper or just on their table. They have to select 9 images, make sure they don't move them around after they select them, lay them out, and you're just trying to find 3 in a row. So it's almost like a bingo, right? But what you're doing is everyone's going to have a slightly different board because there might be 12, 15 cards to choose from. They could put them in any order. They simply have to make a 3x3 grid, and then you call out, but instead of showing what you want them to find, you're calling out the restrictions on the domain and the range. They have to match it, and then maybe they flip it over if they call it. You're looking to see which student can get 3 in a row first. And then any of these graphs, right? That's all we're wanting to do here is just to recognize what is the domain and range here and how can I represent that with inequalities. So just have that as a bell ringer or an exit ticket, just a real quick review. All right, our next activity is called Race to the Inequality. So this is going to be a full body movement for some of our students here. You're going to ask for or either designate 10 volunteers. You need the first 10 are each going to represent a digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You want them either printed up really big, maybe written on whiteboards. They are that digit. Okay. The remaining volunteers will either be X or Y, depending on whether you're wanting to focus on the domain or range, and then each of those 4 inequality symbols. Now, the rest of the class is going to be split into 2 teams. What you're going to do is you're going to display the graph of a linear equation on the board, and then the 15 volunteers that represent the symbols and each of the digits, their back is to the screen, so they can't see what's there. They're simply going to be directed. The first team is told to either represent the domain or the range, so have that up there and say, all right, guys, represent the domain or the range, and then they have to direct the 15 volunteers. Obviously, not all of them will be used. They have to arrange themselves to either represent the domain or the range as quickly as they can. The only thing you need to watch out for is make sure you're not representing the same digit twice. If you need a 2 and then you need a 12, well, that's not going to work because there's only going to be one digit 2. And then you need to reset the volunteers, let the second team do a different linear equation trying to beat the time of the first team. But it will be chaos as they're yelling at their classmates to move. It'll be a lot of fun. And then, if you have a smaller class, how can you do some variations, right? Each volunteer can maybe have 2 different digits, right? A 0 or a 1, or 2 different symbols, but you're going to have to be, 1 in each hand, so that's fine, right? If you want for some alternate scoring options, instead of competing against each other, they're just competing against the clock. So maybe they get 5 points if they solve it in 20 seconds or less, 4 points if they solve it in 30 seconds or less, and so on and so forth. And then for an extra challenge, maybe they have to do both in succession. First hit the domain, reset, and then do the range, and then that's your time. And then you can use domain and range limitation that require 2 digits like 21, but you still going to have to make sure that you're not going to use the 2 or the 1 anywhere else. But that might throw them for a loop if they're used to everything being just 1 digit. If you give them a 35, like I said, you're just going to have to manipulate the domain and range so you're not repeating a digit twice. And then our final activity here is discrete challenge. Okay, so we want students to create and solve word problems for linear equations that have discrete data sets. That's going to be a little bit tricky. So you want to, A, make sure students are very clear about the difference between discrete and continuous data. I've linked two different examples, and when we've seen this on the star, one of them is right down here. This is from the redesign practice. And you see they give you the word problem. They go ahead and give you the actual equation. They just want you to find two correct statements about the domain and range, and the answer here is going to be not continuous, but it's going to be from these discrete data sets. So what you want to do is you want to put students in pairs to work together to write problem situations that represent linear equations with discrete data, and then each pair swaps their problems with another pair and solves for the other domain range, or both. So the challenge here is to be able to write or create a problem situation that represents discrete data in a linear equation relationship. So some students might need extra support. So you can provide them with the problem situation and then allow them to use that context to write a problem. So you might say, you're saving the same amount each month to make a large purchase. So then they just need to come up with a story problem that incorporates how much is the purchase, how much are they saving each month. Some students, you simply might need to give them the actual equation, right? So this is from this previous problem. Look, f of x equals 480 minus 96x. Say, guys, that's the equation. Write a word problem around this. And obviously you're going to want to go ahead and clear it to make sure you're going to get some good discrete data from this, most likely integers to begin with, right? But you can go ahead and feed them the equation, simply have them work out what the problem looks like. If you got any high quality student problems, these are good. Don't throw them away. Use them as bell ringers, right? Certificates for the whole class. And then students can also work on creating a graph of their problem because maybe they need to be able to represent discrete data graphically. How do they show those dots as opposed to drawing that continuous line? So these are the different activities that I came up with for helping your students with A.2A. I hope you find this useful. And you can find the link to this blog post in the video description.